Good evening, Absurdity fans. You remember that feeling that you used to get, right, when you're at school and you sat down, it's a math lesson or something, right? And just about everybody in the class is raising their hands up. Ask me, sir, I know. Ask me, miss, I know. And you don't know. Do you remember that feeling? I used to get this, not a panic, not a fight or flight feeling, but it was just this, don't ask me, I don't get it, I just don't fucking get it, right? Now, somebody private messaged me 3 hours ago, right, in the afternoon. Couldn't understand, we'll call her S, all right? She couldn't understand the bold bit. She couldn't really understand a lot of it, right? So 5 minutes went back and forth. I said, listen, I'm gonna go over it again on the board, right? I get it, I do get this because it's a worry, right? That so many people can't relate to this, wouldn't know how to use it. Because if you did know how to use it, you would see what I see. It seems like everybody is traveling at the speed of light at the moment. You are, Uncle Bob, Uncle Nelly, and you're all going around event horizons, aren't you? Toying with death. All of these, if we do this at the speed of light and we do that at the speed of light, but folks, this is more important than all of that put together, right? Because this is the stuff that you need to know. If you don't know all of this stuff, you're not going to be able to work out what's wrong with all of the other stuff. You can't go to the other stuff without doing this stuff. Because what's happened, everybody's around the other stuff, and when one of us says something, yeah, but no, Einstein did that, shut up, you don't know what you're talking about. Well, that's the knowledge, right? Somebody else says something. No, Christian Huygens sorted that out. Oh, Römer discovered the speed of light. You all know these people and what they did, but did they do it? See, we are down by the did they do it? So we're working these numbers out. It's important if you don't get this. If you don't get this, you'll believe anything, right? Because you don't know how to problem solve. Listen, this is a fact, right? So E goes outside, right? I'm doing this for S because she private messaged me, but all of a sudden I get it. So many people saying, read a book, science, learn some science, go back to school. Excuse me? People, this is the basics. This is the working stuff out to see if things are as they are and things are not as they should be, right? So S, I'm not going to say your whole name. Right, are we ready? I'm going to be patient because I get it. I'm now talking to myself at the back of the class, right? So I don't want to stress him out, okay? We have a sun and earth. That's the moon. How do we know that's the moon? Because that's Daisy the cow, okay? I always draw a Daisy the cow. Earth, sun, 150 million kilometers. Let me just add something. This is what they are telling us. If it turns out one day to be 180 million, don't come running to me. I'm using the numbers that they give us, okay? 150 million kilometers between the sun and planet Earth, right? What we have is a sun with a diameter of 1,390,000 kilometers. We divide this distance by the diameter of that sun, and we get 108 suns. 150 million divided by 1,390,000 is 108, or 107.9 something. We call it 108. Boom, 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 right? 108 suns. Now, we are told that it takes 8 minutes and 20 seconds for the sun to radiate its light and for it to reach planet Earth, okay? Now, what we do know is that distance, that 8 minutes 20 seconds, we can break that down into 108 suns. If we divide the sun's diameter by the speed of light, we get 4.6. The reason we get 4.6 is because the sun's diameter is bigger than it takes the speed of light to travel 1 second. Okay, so we've got 1 second, 2 seconds, 3 seconds, 4 seconds, and that would be a 0.6. All right, 0.6. So that's 299,792 kilometers there, and there, and there, and there, and there we have. Alexa, what's 299,792 multiplied by 4?
299,792 times 4 is 1,199,168.
Right, so we've got 1,199,168. There. Alexa, what's 1,390,000 minus...
1,003 is a number.
Alexa,
1,003 is
Alexa, what's 1,390,000 minus 1,199,168?
1,390,000 minus 1,199,168 is 190,832.
Right, there's your 0.6. All right, so you've got 299,792 kilometers there, and that 0.6, 4.6 is 190,831 kilometers. Okay, or was that 2? Did you say 2 or 1? Anyway, right, 4.6 seconds. That's the breakup. That's it broken down. That's where the time is going. So, 4.6 seconds for the sun to radiate light the distance of its diameter. 1 second, 2 seconds, 3 seconds, 4.6. For a total of 8 minutes and 20 seconds. What that means is, on your marks, get set, go. 108. 4.6 seconds. 4.6 seconds. 4.6 seconds. 4.6 seconds. Now, think. All right? We've got the Earth's diameter over there, the sun's diameter here. We've already done this one, 150 million divided by 1,390,000. Over here, we've got the sun's diameter, Earth's diameter. We divide the sun's diameter by Earth's diameter, we get 109. This is for depth, informative. It makes sense to do it to keep things to scale. It just broadens your knowledge of what's happening with the 3 things, right? So we've got 109 Earths inside the sun's diameter. It's a constant. It doesn't matter where, when, or who you're with. That is a constant. Same as the 108 suns, between the distance, right? So, S, this is what we're going to do. I've done a 3, I've done a 5, haven't done a 4. We're going to use a 4mm bulb. That is going to be the sun for this exercise, okay? 4mm bulb. And I'm not, when I was saying the other one was 3mm, right? I wasn't exaggerating, look at this. So this is the bulb that we're using. That thing in the middle, a little tiny, there you go. Right, so I'm not going to be able to hold that, but you still see it. If I put that up, you'll see, I'm not lying, it's tiny, right? Maybe 3.1mm at a push. Anyway, for this exercise, it's going to be 4. This really doesn't matter, right? It doesn't matter. It's all with the speed of light behind it, and my God, we can mess about with 1 millimeter here and there. So we're using a 4mm bulb for the sun, right? Now, we know that the distance between Earth and the sun, there are 108 suns, right? I'm going to use this bulb for the sun. Its diameter is 4mm. All we do is multiply it by 108 and we've got the 108 suns. It's perfectly to scale, right? You don't have to do the whole, oh, work this out, work that out, how many kilometers and then percentage. No. The sun's our measurement for this, right? So we've got 43.2 centimeters. If the sun were a 4mm bulb and it's that sun's there, I only put that there just so we know it's the sun. But that bulb, it's probably about just over 5. So if we brought the sun down here and we shrunk it and we put it there, 43.2 centimeters, right, would separate Earth and the sun. Now, Earth, you can't even see it. If the sun is 4mm, Earth, we get 36 micrometers. How do we get that? We know there are 109 Earths in the sun, right? So if we divide the 4mm by 109, it will give us the diameter of Earth. Alexa, what's 4mm divided by 109?
4 millimeters divided by 109 is approximately 0.0367 millimeters.
No need to shout. 0.367. 0.0367 millimeters. That's 36 micrometers, right? There are 1,000 micrometers in a millimeter, right? 1,000. So there are 10,000 micrometers in a centimeter, all right? So Earth, we wouldn't see it, a speck of dust. Right, we are here, crunch time. Why can't I answer? Why would the bulb take so long? You need to understand something. This is to scale. We have brought everything down to scale, right? In the same proportion. Everything. It's like we're looking at the sun and the Earth from a distance from Jupiter or something, right? It's to scale. What we expect now is for the light source to take 8 minutes and 20 seconds to get to Earth. That's between that line and that line, by the way. Right, now this is important. This is the bit that people aren't getting. It's not going to go, we wouldn't expect the sun, the one that we have up there, if we shrunk it down and put it there, boom, it was 4mm, we wouldn't expect it to go whoosh like this. It can't, because it's all to scale. There is 108 suns in between here and here, and it takes 4.6 seconds for each sun diameter. Everything is brought down to scale, right? So what we're expecting to see now is when we turn the bulb on, if it were a bulb that acts like the sun, for each sun diameter, it's going to take 4.6 seconds for the light to radiate, just like it does up there. That's what we expect, right? If we had a bulb that behaves like the sun. So let's see what happens, okay? I don't need to turn, yeah, let's just turn it on, might as well for the effect, hey? Alright, I'll turn it on. Alright, so we're going to turn the sun on. It won't be much of a show because it's going to take 8 minutes and 20 seconds to reach the other line. Now, bang. Alright? Now, what we were expecting was this light source, the sun, to take 4.6 seconds each diameter, right? For a total of 8 minutes and 20 seconds from this line to this line, from sun to Earth. But that didn't happen, it was instant. So what is out here? Well, I'll tell you what's out. What we need is a bulb that radiates its light at 4.6 seconds per diameter, because that is how slowly the sun is radiating its light. Now, a sphere is a sphere. It doesn't matter if it's a basketball, a bulb, 4.6 seconds. It doesn't matter how big you get, does it? This is it here. Why do people think that as it gets bigger, the light is going to slow down, right? Things get more powerful. We are talking the sun. Do you think if I brought that sun down here, pound for pound, and shrunk it right down to a size of 4 millimeters, right? Do you think that I would be able to hold it, for example? No, because it'd be fucking hot, wouldn't it, right? Even though it's small, it's still the sun. If we took a little spoonful of the sun and brought it down here, right? But this bulb is kicking the sun's ass, right? So the only way to prove the claims that the sun takes 4.6 seconds to radiate its own light, the distance of its own diameter, is we need to find something that radiates light that slowly, right? We have to, because these claims are so illogical, right? Especially when you consider UY Scuti, the big star, right? 2 hours and 12 minutes with a diameter of 2.37 billion kilometers, it would take UY Scuti 2 hours and 12 minutes to radiate light the distance of its diameter. Now, you have, look, it's about common sense, people. All you have to do is look at the sun in the sky. You honestly think that from the sun to Earth, the 108 diameters, that it's going to take light 4.6 seconds to travel the distance of each sun? I mean, come on. Because that is what they're saying, right? Now, I hope you understood this, right? So you said when you see it, you message me, because you are a good gauge of what people could and might not be understanding. But people, nothing radiates light that slowly. When you bring something down to scale, right, like this, and everything remains in the same proportions, what you see is what you get. Now, we are not getting what they're saying the sun is doing. The reason for that is because when the sun turns on, right, we'll just use this other bulb now, and it radiates its light, because light is light, isn't it? Shouldn't matter how big something is, should it? When we turn it on, we're expecting 4.6 seconds per diameter. 4.6 seconds per diameter. This is not as powerful as the sun, but it's all we have. Oh. Down to the river in a second. Now, again, one of you science fans might know where we can get a bulb that radiates its light at the distance of one diameter of whatever bulb we're using every 4.6 seconds, right? That is where the alarm bells were ringing. And people, this isn't the speed of light. We're not traveling at the speed of light here. We're at home trying to work out. Well, we're not trying to work out, it's worked out, right? People, you need these basics. If anybody doesn't understand this, nudge me, right? Because this is probably right now the most important example of a calculation you need to know, because it's people keep saying to me, well, why should I believe you over the scientists and this and that and the other? You don't want to believe me or anyone else. You need to know for yourself. Damn it! Don't you get it, right? You don't want, oh, your matey from the pub told me. Yes. No, work shit out for yourself. I am giving you the best piggyback, right? This is, it's worth its weight in gold. If I scooped all that dust off, it wouldn't even weigh a point. I might get a couple of points out of it. I mean, like a gram point, you know. People, this is where it's at. If you think you're smart because you're working out the speed of light, Aunt Nelly going one way, you going the other way, and a parrot in between doing nothing, you're not smart. This is the building blocks. If you don't have these building blocks, what are you doing up on the top floor? You'll believe anything. No wonder you get angry when we bring these things up, because you don't understand them, right? All right, peeps. S, please message me when you've seen this so I know that you've got it. I will go over it again and again and again until everybody understands for themselves. All right, peeps, laters.